All right. Well, I want to welcome everyone to a look at structurally insulated framing systems, SIFS, and saving money within the walls. This course is proof for 1 hour in continuing education units CVCI, NARI Green, AIBD, Certified Green Professional, Certified Green Home Professional, and DPI Non-Whole House, as well as AIA HSW, which may make it applicable to your local state-based design or contractor license. Today I'll be your moderator. My name is Brett Little, and I am the Executive Director here at the nonprofit, the Green Home Institute. So for this session, we're going to be discussing a new way to look at wall systems to maximize energy efficiency, but in a more cost-effective way than you might be looking at through conventional systems that you've heard about. That's our ultimate goal here today, and very excited to be announcing our speaker, Brian Idris, inventor, has a degree in architecture and has designed over 750 structures that have been built, including homes, additions, apartments, condos, townhomes, commercial buildings, and more. He's also a journeyman carpenter and formerly was a certified energy auditor for NST during the first oil embargo days of the late 70s and early 80s. Iverson brings many stories that paint pictures of better building wall systems. So Brian, thanks for joining us, and feel free to take it away.
Okay, sounds good. Hopefully everybody can hear me just fine. We forgot to add one more thing on there that I've done. I actually started out back in 1974 doing drywall work. So I can't say I'm a journeyman sheetrock taper, but I can say that I did end up with back surgery in 1988 from hanging sheetrock. Okay, so I'm going to do my darndest to not flip back and forth here too much along the way. I'm going to try to stick with the presentation as it is. When Brett and I gave our first go around at in Grand Rapids, Michigan, we had so many questions that it took us 2 hours to get done with a 1 hour presentation. So as long as you want to go, we'll keep on going. But being the new kid on the block, we know that there's going to be a fair bit of questions on how to build. And so anyway, let's get into the presentation as a whole and start diving into it, and then you'll learn as we go. The structural insulated framing system is the complete wall assembly. So it was designed to replace 2x6s, 2x4s, staggered stud walls, double walls, the whole entire exterior of an assembly. It was designed to replace every component in that wall. So bottom plate, top plate, studs, cripples, king studs, jack studs, sill plate, sole plate, all the way through, 100%, including the headers. And I know that other companies have, along the way, they've tried to make header material, sandwich headers in the past, and they've never really gone anywhere. So we've tried to, the system tries to do its darndest to simplify the process of framing in the field. So we're going to start out talking about hot tubs, I guess, and which is pretty much where the whole some of the equation started from. I've spent a fair bit of my life in Canada, and 35 below zero. And when sitting there at night and the northern northern lights come out, and it is 35 below zero, 40 below zero, you kind of sit there and wonder how much does it cost these people to keep that water hot inside that hot tub when it's so cold on the outside. And that's pretty much the premise of the structural insulated framing is what is the right amount of foam or insulation to have in that wall to minimize transfer from one side of the wall to the other. And hot tub manufacturers have at a minimum of 2.5 inches of foam on that cover for a reason, and that is to minimize how much heat loss that there is. And you know, it's the opposite is true in the South when it's San Antonio, Texas, and you're trying to keep your hot tub probably cooler than we do in the North. And there's another slide coming up here later. We'll talk more about that. But our goal was, or the product's goal was to keep that insulation to the maximum amount possible to get that thermal break through the entire wall assembly. The next photo is a thermal bridging on the remodeling side of things. There's a huge push to make existing structures in the country, in the world, more energy efficient. And I took this photo a few weeks ago up in Montreal when I was up there, and this is done a lot where they strip all the siding off the outside, then they strip it with insulation foam, and then over the top of that they put battens down. And another way to do this is to maybe use a little smaller thermally broken wall stud and put in there in order to be able to get the thermal break along the whole entire outside of the perimeter. So what is thermal bridging? I have a couple of slides in here to chat about, but obviously when you look at that, I mean, it's kind of a little easier here if I had you in person. I could just show you, but the amount of transfer that you get through a wood framing member or a metal framing member is astronomical. And in order to minimize that, you need to create some sort of a thermal break through it, or you put foam on the outside, or rock wool, or some of the other products that go on the outside of the structure. And there's quite a few things going on in these photos right here. The first one I'm going to point out is the product itself has the thermal break through the middle of the wood member, so two 2x3s on the outside with a truss in the middle, and then a foam core. And we've been trying to do a big education process on how to build and how to construct. Advanced framing, not everybody knows how to do. Not everybody knows how to do one top plate. And in America, United States, we're able to use smooth bore nails to nail. In Canada, for the most part, they require a screw shank or a ring shank nail. So they build to a different standard out the gate. It's kind of like us here in the United States. We build to a 30-year standard, and we hope and pray that the structure is still standing at the end of the first mortgage. And I know some of you are smiling. And in Canada, they build to maybe a little bit more of a 100-year average. But in Europe, they build to a 400-year standard. And you see a lot of screws used in Europe, and that's what we tried to put together here in this slide. Using 4.5-inch screws, you only have to use one screw in each wood member to attach the bottom plate to the stud and the top plate as well. Otherwise, you have to use 2 nails into one wood member and 1 into the other, just the same as what you have to do on a 2x6. And over on the left-hand side, you see the header above that one thing. That header was actually pushed all the way up to the top plate in order to be able to use the strength of the top plate as part of the header design. And then on the right, what you would have to do is drop down a nailer for the top of your window. We can only limit our wall height to 8 feet at this conference, so I wasn't able to show it all 100% in here. But there is a 99.23% complete thermal break through that entire wall assembly. And so if you look at the alternative, putting foam on the outside, if you have to put that foam on and you obviously attach that with nails, the diameter of those nails just to put it on equals a 1/2 inch. And the diameter of your siding fasteners running through that is another 1/2 inch. You end up with a 99% complete thermal break. Not trying to split hairs, but doing a thermal doing your darndest to build a product like this and trying to get as near to 100% complete thermal break has been challenging, to say the least. So in this slide, the one on the left is a typical 2x6. You can see the thermal bridge. The little yellow line on the outside is the foam on the outside. On the right is the structural insulated framing system, and then you can see the thermal break through the stud itself. And the advantages for heating and cooling is the same. The goal is to create an atmosphere that you live in and have a controlled set of circumstances of heating and cooling on a daily basis, a yearly basis, to minimize the amount of energy that it takes to keep that indoor environment at a constant temperature. A lot of a few of the energy programs that are out there don't actually take into account a product like this, and so they have to do some studying to actually see all of the benefits. But there was a gentleman from Wisconsin, probably one of the top guys there on the thermal energy side, came back that using this type of a system makes the floor, the main floor, or the house structure itself, up to 28% more energy efficient on the heating side, and which is an astronomical number. But when you consider the sum of the whole, when you look at the whole benefit, he came back as using a structural insulated wall system, you can have a 10% increase in energy efficiency when you take into account all of your basement, your rim, your walls, your windows, your doors, and your roof as a whole. Just by switching this part over, you made the whole house 10% more energy efficient. And again, that's a big number for what you have for a cost to actually do this. This is just an exterior wall for the most part that we're talking about today. We're not talking about the sound transmission rate on party walls. So this is an exterior wall application only today. So somebody just asked, are the inside and outside elements rigidly attached? There's a complete truss system that holds it together. It's similar to a roof bar joist, let's say. So every 2 feet is a wood dowel that's glued together under the same rules as an I-joist or finger jointing. So you have to, they call it creep tests. You have to no creep, and you have to use the same adhesives to put it together to be structural. So I'm not sure who all is on the webinar here, but if you're if you know much about the finger joint, the long finger joints are what you have to have for a top plate header application. But we have to pass all those same tests for all of our studs and the same results. So yes, there is a massive truss system that sits inside that foam core. It's buried inside the foam core. All right, I'm embarrassed to say that this is the back of my house. My house was built in 1989, and I think on this day it was around 80 degrees outside, give or take, when we took this photo. But all that yellow and red, that's all heat loss that's going through the back of my house. And it's pretty embarrassing. That is not the goal of where we as society want our structures to be built in the future. In fact, it's completely the opposite. So on this next slide here, all right, so this was the first try to do a structural insulated framing system for the floor, the walls, and the roof. And on this day, it is 54 degrees outside temperature, and it is over 110 degrees on the inside. And we were trying to get to be able to see the studs inside the wall, and we just couldn't do it. But that's the route that everybody here on the phone, I would hope, on the call, wants to get to, so that you can reduce those energy bills. We can reduce our carbon footprint. Carbon's a big deal in our environment now today, and that's where we want to go. So the structural insulated framing system is not just a wall system, but in the future they're looking at having floor and roof members as well. And I was told that there was going to be a roof truss manufacturer that's going to bury the system as the bottom cord on a roof truss. Just an FYI. Insulation. In this slide here, and I took this off the internet, and I'm sorry for whoever made it up, but they did a great job, and we didn't feel like redoing it. So the exterior elements of a wall, it's hard to know. The internet, this says anywhere from 24 to 25%. I saw one modular home company that I guarantee you used pushing 28%. That's the most. I'm not sure why they use so many boards, but it looked like they had one every 12 inches, but they ship from the United States up into the Yukon, so maybe they're trying to minimize cracking on the walls. But in this one, shows 25% of the walls have wood in them. I'm going to say that that's probably a pretty fair number on the high side. 22% might be more like it. Having designed a number of places, I designed them. I said I didn't stamp it. I'm not an architect, but having been a realtor and a developer my whole entire life, you end up designing a lot of the properties on the lots that you developed. So I try to tell everybody I'm just a dirt guy. I've moved 100 million yards of dirt, but using the structural insulated framing system, and we're going to talk about strengths in that. Everybody so far has used that 24 inches on center because of its structural advantages, and there is one that's going to be at 16 inches on center here because they're doing stucco on the exterior, and obviously stucco is not allowed to be applied on anything 16 inches on center or yeah, I see Thomas just wrote in regarding the truss system. You're right. We will send out to everybody a picture of the truss itself. And you're right, we did blow that. Okay. All right, this is the exterior of a building. Again, I picked it off the internet, but it shows pretty well. This system is not just a residential system. It's a commercial system as well. Multifamily, apartments, hotels, motels. Every curtain wall in the world. There's been a number of calls from the world asking for this, especially in places where the temperatures are extreme. And we'll talk about that in a bit. But the curtain walls are being replaced from being all glass to having a fair amount of insulation in them in order to reduce these astronomical costs that it takes to keep these buildings heated and cooled. Okay, so we're going to go to old school. Go back to the turn of the century of the 1800s. We used to do all balloon framing back then. I've done plenty of remodel work on structures that have been fixed over the years and remodeled over the years, hundreds and hundreds of them back in the 80s, dating myself a little bit. But balloon framing was the normal route to go. And so you buy as long a lumber as what you can. Hopefully it's straight. Hopefully it's straighter than what you can buy today. And then we switched over to platform framing in the 30s, about 20s, making it easier to haul lumber and logs. I feel bad for all them loggers on horse and sleigh moving 24, 30-foot logs, a feat, to say the least. There is testing being done to be able to use this system as a complete thermal break through the rim and back to a new balloon framing system where all of the floors are hung on the inside of the wall stud itself. And the next slide shows that pretty well. this system is able to solve a multitude of challenges in the field, and obviously I've been around a lot in my life, and looking at thousands and thousands of buildings and structures. And so when I thought of this idea, sitting in North Dakota, and my favorite line for North Dakota is, "When the wind blows, there's no place to hide." And my friends tell me that when your dog runs away from home, you can still see it running 3 days later. Sorry, had to interject that in there. Okay, so the next slide here is the curtain wall applications. Connections will have to be done on every single application, but it's easily to be able to pull off on the exterior skin of any building. And the connections I've seen them. I've been part of them on the metal side. And so wherever you have an application, whatever kind of material that's out there that needs to be held, this system can be designed to hold, it can be designed to hold brick, 12, 14 feet tall on a wall without a problem. It already holds hardy board siding, 2 to 3 pounds a square foot without a problem. There's
hey, Brian.
Yep.
I saw mentioning, code compliance up to five stories. Is there any ability for it to potentially ever breach that, or do you think that's really these SIFS systems kind of get limited at that level?
Okay, so you're gonna go into this. No, there's so right now the system can hold 8,600 pounds per stud. Let's say when those wood members were turned perpendicular, they solved for the material to be able to deflect in the x-axis. So that's the 1.5-inch dimension of all 2x material. It's the dimension that all LSL and LVL studs are done in. 1.5 wide or 1 3/4 wide for some of them, and they all fail under compression load in that x-axis. When the wood members were turned perpendicular, what ended up happening is, granted the stud got made a little bit wider, 2.5 inches, but with the truss inside, it held it all together to act like a solid member, like in this case a 3x6, and the compression of this can hold so the maximum load is 8,600 pounds, but the maximum load a 2x6 bottom plate can hold is 3,665 pounds, which is perpendicular to grain. If we used a 2.1 ME, can't lift off the brand, but like a MSR board 2100, we can get up to 5,600 pounds on that. If we stuck a metal plate to displace the load on the bottom of the stud, between the stud and the bottom plate, we can actually get up to 8,600 pounds. So there is a system made to be able to get there, Brett. There is testing in place that there are studs that'll hold and will be certified to hold in excess of 10,000 pounds apiece. So that's a long ways around, but we're doing all the testing at 24 inches on center, and yes, we will be able to do 6-story buildings in the future, but we're talking a $1 million investment to be able to breach the 5-story. So we are certified right now to build 5 stories in all of the United States, including all 6 zones of seismic zones in California. Okay, there's I was at an insulated metal skin company where they put metal skins, and they have anywhere from 2 to 6 inches of foam on each side. So this system can get buried inside of their wall panel pretty simply, so that all the exterior elevations that you do, if you're commercial architects, steel people, all those commercial exterior walls that are non-structural will be able to be structural in the future. Pretty fun fact. This next slide there's a multitude of ways on the commercial arena of trying to be able to create sound deadening in walls and minimize transfer and whatnot. And I just picked this off the internet. It's on the steel application. I'm going to give these guys credit on what they do. Granted, it's not a cheap endeavor here. Okay, advanced framing. Of all of the structures that have been built so far, the advanced framing has been the largest challenge to educate carpenters in the field, framers. They just, if they don't do it, and if they've never done it, they have no idea. So that's really where the education needs to come in. It's not in the product and using the product itself, it's in educating the carpenters on the field. And I know, I went to school to become an architect for a few years first in 1979 to 1981, and then figured out I couldn't sit at a desk the rest of my life and went back to being a carpenter. But in all advanced framing, you have to use the metal straps, and you can buy them in a long roll and then just snip them off in the field. And obviously they have to go 9 inches one way and 9 inches the other, so 18 inches on the outside and on the inside. 23 inches on an outside corner is what you have to cut those strips at. 23 and a half, I think. Okay, go back one there. All right, on the left. Having been in the construction arena for 30 plus years, some things look sexy to me. That header, this is the very first structure that was built, and it has a dirt roof on top of it, and it actually holds the weight of a 4-story building. So that header right there is 24 inches tall, microlam, or I mean LSL, LVL. It's an LVL, 24 inches tall. There's 3 of them in there holding up that roof, and it's only held by 2 cripples underneath that to hold it up. That's it. That's the structural strength of that system itself. In typical advanced framing using 2x6s, you have to make all of your roof trusses and floor trusses line up in a dead straight line, running up and down, because the 2x6 for your plate material can't hold any weight to the left or to the right of the stud. In this case, we can go 7-8 inches either side and still hold the load, because when that top plate is actually a little mini header. So in the south, where there is no snow load, that is the header of a single wide Rambler, 4-foot wide window. The top plate is that strong that it can just be the header if they wanted it to be. So it is 1.5 times the strength of 2 2x6s in plank, and you get by with 1 top plate. So there's a lot of lumber. The average house, it's easier to talk about houses than numbers. The average house in America is 2,450 square feet in the United States and Canada today. So that's roughly 200 lineal feet of top plate you don't have to have. With the structural advantages of the T-stud, there's the truss. With the structural advantages of the product, you can, holding 8,600 pounds, or in a typical SPF world, 3,665 pounds. It is 4 times superior, even at that, than a 2x6. And so on average, you save 58 studs on average less, and you've built a more structural house. On the left, you see the truss system in there. There's 2 dowels per every foot. They're buried inside of those wood members, and we hold 1,000 pounds roughly and only 1/2 inch of deflection. So we've actually passed all of the hurricane testing for all of Dade County, Florida, at 220 miles an hour. Somebody didn't send along lateral bracing because they forgot, i.e. me. So we actually passed all the testing without lateral bracing at the 10-foot mark that you have to have for fire blocking. So we've done some testing on LSL and LVL, anywhere from 1.9 to 2.1 ME, even finger jointed lumber up to 2.1 ME. It's pretty fun to be able to see the walls themselves. You have to do a 3-studded wall. They do a force break like it has a 120-pound snow load on it and the roof truss is tipping, they mimic that action when they do a force break wall. And we typically have walls that hold 37 to 40,000 pounds all the time. And again, we're at the point of crushing the plates long before the studs give up their load. There will be, I've been told, products coming out in the future that will be completely fireproof. The foam has a fire retardant in it, but maybe fireproof is too big a word. But the fire retardant on the outside, and I see I listed off a brand name there. It's a mold, rot, termite, and fireproofing all in one, and so that is coming shortly. And the Wallmanized 2x3s only come in 8 feet. I guess if somebody knows of some longer ones that are still straight, great. But the way the codes read, at the end of every plate, you have to have an anchor bolt within a foot or something like that. You have to end up having to put in double the anchor bolts if you have only 8-foot members all the way around. So I don't think that's very cost effective. Somebody asked health and safety considerations with insulating foam. We'll get to the foam here shortly. We'll talk about that foam member a little bit. There's again the truss. As it sits right there, the GWP is under 1. Most foam that's still used today is what we call the old school. So we like to say that we have our green hat on, but we switched over to a different blowing agent that is 2020 compliant. And when we did that in the last month, it changed all sorts of equipment at the shop at the same time. And the foam works a little differently with that truss system in there. And we've had to dial some things in. We're trying to reduce the density of the foam down to get the highest R value and the highest sound transmission rate through it. So it is it's an HOF. Typically, Honeywell has designed it first. I'm not sure if they're all the same. They all fall into the same formula on that, but no formaldehyde. Somebody asked, do SIP panels, SIFS, I'm going to assume that you typed in, you said do SIFS. We're a SIF, structural insulated framing system. Have we passed a 285 test for assembly? There is an assembly test coming up, but obviously, as everybody on this call knows, there's 100 different assemblies, and I wish somebody would just pick one. So yes, there is an assembly test coming up shortly, but we'll get through this, and then you'll see what's been done so far. Okay, so the structural insulated framing system, the number one nemesis in construction industry is how to stop that heat and cold transfer through a wall cost effectively. It's a 6-in-1 solution. We say that they're up to 18% more energy efficient than a standard 2x6, and that is dependent upon, we use 16% here in Minnesota because the cavity is required to have an R21 in climate zone 7, so half the state here is 7 and half of it is 6. So in climate zones that require a 19, we're actually, in our 19 in the wall, we're actually 18%. The stud itself is 8 times stronger in compression than a 2x6. The sound, and we'll talk about that in a little bit, we're actually right now tested out as a +6. We're equal to putting RC channel on both sides. We passed all the wind load and the seismic zone. We'll talk about fire rating in a little bit. We'll talk about the mold and rot resistance. Okay, so in the early on days, we had one stud held 12,655 pounds by itself, and we tested up a bunch of 2x6s, and they were all failing. The maximum load that they held was 4,200, and a 2x6 for the most part is only certified to hold 900 pounds. number to select. The R value calculating, we'll get into that in a little bit. 20.2 is what our initial is, and the 2x6 is obviously 6.88. We have a 99.23% complete thermal break through the wall assembly itself, all the way from the bottom plate to the top plate. We passed all that hurricane and seismic testing, the making walls 22% quieter. I get sick and tired of staying in hotel rooms, and at 2 o'clock you get woken up by the person next door. We've solved for the x-axis on the structural side, and then we went to solve the y-axis on the fire side. And we'll talk about that in a second. I know the slides that are coming up here. The HERS score rating, and I know that there's a concern out there on, is that still a current up-to-date system? I don't know that answer. I'm not an expert in that field by any stretch of the imagination, but the first company that we had test and do the our energy efficiency tests and stuff for us, they came up with that there would be a reduction of the score of anywhere from 4 to 7, depending upon the climate zone that you're in. There are 19 states working on energy rebates with us right now, and we hope to have most of those in place in the next fiscal year. Hey,
Brian,
yep.
On that HERS reduction, is that in comparison to just a conventional wall that has no exterior insulation, or how is that 4 to 7 being compared?
Yeah, there's no, what they did is they took a house that was standard built for Minnesota, so 2x6 walls, it was a new house, R21, and in the wall insulation cavity, but no foam on the outside. Nothing done different than what is standard for code. And they again manipulated that. I'm not sure which system that they used, but they manipulated the stud to be, they pushed all the studs to one section, changed the size of them, changed the R value of them, is what I think I was watching that they were doing in order to come up with a score. And because we are the unknown kid on the block, that these companies are now starting to figure out that we're coming. It's difficult to talk and to get these programs to understand what it is that the benefits are of being able to, what I call, absorb the energy one way or the other through a wall directly through the stud. So it's not a for a fact number, but we know it's a big number. So I hope that answered your question. We'll talk about the fasteners. We can pretty much be done with this page because we're going to cover the rest in just a second here. Okay, structurally, architects and engineers, we will be on StructCalc, and shortly, we were hoping to be there already. All the sizing of the wind load, the headers will be in there. All the studs will be in there. So there will be a third-party program to go to that has all of our information already out there. Everybody wants to know this one, and we do have our. There is a stocking yard here in the country now of the product as we ramp up production, and so we are going across the northern tier of states with building permits today in 4 states. But it appears that the average upcharge to use our system over just 2x6s, I know 2x4, 2x6 is 16 inches on center versus this product at 24 inches on center. One top plate versus 2 appears to be $1,300 extra on average today. There was a structure built 2,850 square feet plus a full basement walkout, and the assembly took into account all of the headers but 2. And the retail markup from that lumber yard was $3,300 extra, and so it created the same U value as putting foam on the outside for considerably less. And the pricing part is brutal to get into because I don't know what the retail markup is, and there's trucking and logistics involved, but it appears that to get that 0.0425 U value, that we're going to be about the same price as putting foam on the outside plus the studs, but you save all the labor of putting the foam on. And I'm going to say that more than likely we're a significant number underneath that, depending upon where you're at. And as we ramp up production in the other states that we're already aiming at, we'll be able to minimize those logistics challenges that we have today as a startup. So that was a mouthful. Okay, so the solutions that we set out to solve in these, again, these are photos I picked off the internet, except for the one on the left is my house. I would never say that the photos on the right were my house, but they could be. Anyway, you can see every stud, you can see every lateral brace in that house. It's alarming, but I can see why houses that were built in the 70s, back when we still had 2x4 walls, had such mold issues. I can understand that. Moisture barriers have advanced a lot since then. We've made incredible headway in the system itself, and there's still room to go. This is where we want to get to, and I know that everybody says, yep, it is. That's our goal, is to get that. I'm sure that is every company's goal that's out there, and the plus side for us is we want to get there as being the cheapest, strongest solution that there is. All right, heating. This is a redneck test. I'm from Minnesota. Okay, you got to forgive me now. We heated up one wood member to 192 degrees, and that bottom member, we only had 3 degrees temperature transfer after 90 minutes. And because we never thought that we would get that far, we didn't take into account convection. So not knowing how the 3 degrees got there isn't necessarily the deal. But what the deal is it costs twice as much per BTU to cool a house as it does to heat it. So we are, this product is just as advantageous in the south as it is in the north and anywhere in the country. You just need to stop that transfer from one side to the other. That's the bottom line, either from the inside out or from the outside in. Just stop it. And don't create any more challenges to that wall assembly while you're doing it. U values, how to calculate U values. Obviously, I'm not a fan of using only the cavity insulation that some programs use. You know, if you have this much in your cavity, you're good to go. I'm analytical, having passed these courses in the 70s where you had to calculate everything out to the square inch, and that's where this came from. I took a house that we built in the past, calculated it all out to the square inch, calculated out every stud, came up with this formula, came up with the 0.0425, then switched over to using the structural insulated framing system, which shows here. And at the bottom, I've listed off what the U values are of typical assemblies. I just plugged and played and put them in. And to get to, you know, people again have asked, you know, how do I want to see walls built in the future? And me, I just, not that I've never been a fan of bad insulation, but I know that 40% of all bats are cut, which means that there's a chance that you're not going to end up with a perfect insulation job. And having done drywall work in the first section of my life and fixing mold issues and like crazy, and you open up the wall and nobody did it right, or they were fast, or it got compacted, I like a blown-in bat. The foam on the outside, foam in the wall, just stop that air from transferring one way or the other and get a perfect job, as perfect as what you can. And but you can see the U values of typical assemblies there. There is a section in California today that already requires 0.039 for a wall assembly. And I know that Brett is probably going to ask me someplace along the way about other products, so I'm going to interject this now, is that there is a 7 1/8 inch deep stud that we are working on. So it's basically a 2x8 or an overall size of 3x8. but our value we're trying to push to with this new blowing agent now. We couldn't do it under the old school blowing agents, but we can with the new blowing agent in the foam. And if we control that foam perfectly, we're trying to get to a 30. Obviously, at that point, we're going to have a hot box test on in order to prove that. So don't quote me on any facts at the moment. But structurally, we only have 5 inches of fiber, but we're equal in strength to a 2x8 at 12 feet. And at 16 feet, we're 20% stronger. So again, we're trying to build the most energy efficient structures that are out there for the least amount of cost to everybody. And again, there's getting to be harder and harder to find labor to build things. So the less number of studs and that you can get by with, the better. And the stronger you can make it, even better yet. More energy efficiency, better yet. Polyisos. I've learned lots about polyisos in the last 3 years of starting this, and I know that some people have questions. We're doing our darndest. We're doing our darndest to come up with the right recipe to make the most energy efficient structures, and yet we have workers that are working with this foam every day, and so we're as concerned as everybody else as far as that off gas goes. And so the company that we're working with today on our foam, they are actually doing studies, and we hope to have a white paper out yet this year. But we want to say that the off gas all happens at the shop. Well, I don't think that that's feasible. But everybody's thinking that it's someplace in the upper 90s as far as the percent goes. Somebody can challenge me on that, but I don't think that the end result study has been done yet, and I don't know how they calculate that, to be honest with you. But all right. So somebody asked a fun question. What about running electrical and plumbing? And I didn't put a slide in for this. I know that for a fact. The electricians, they take out their screwdriver, they poke a hole through the foam. They missed the dowel, but they poke a hole through the foam, they stuff their wire through. So of all the structures that have gone up so far, there's been no drilling, no drills required to push any of their electrical through. Plumbing, on the other hand, and there's a field book out there of how to build and how to put together the structure to avoid the dowels. We did have a plumber that drilled through 3 dowels trying to get that bent pipe in underneath the kitchen sink and up through the outside wall. So in cutting off 3 dowels, we had to do an in-the-field repair because I hadn't done the actually how to figure it out. I thought they'd follow instructions. All right, I know you smiled on that. And so we do have a in-the-field repair guide now to cover cutting off those dowels.
Hey, Brian, sorry, were you still answering that question?
No, I'm done.
Okay, so there's a very specific question here to a very specific place, but I wanted to take a step back to answer it. And so, and maybe you're going to get to this, but the question on folks' mind too is, who is trained to do this, and who's available to do these types of installs, and how does that work? So if you're going to get to that, let's get to it there. But if not, then I wanted to throw that one out there. Okay, so obviously, I've been fortunate enough to be able to have the time to go out and to teach advanced framing on the job, on the fly. There are a number of groups, the passive home builders that are out there who do this automatically every day. It's quite simple. There will be a YouTube video out, another one up here shortly that we're going to film today, and that talks through of what to do and what not to do, talks through the challenges as much as that they possibly can. There's a panel company that out of Iowa that will build these all day long. They've been around. They've watched this process for the last couple of years, and so they're approved to build wall panel sections themselves. But it's actually really simple if you're the carpenter.
take the 2x6 out of the wall and stuff us in. Put 2 nails into one wood member and put 1 into the other. Or if you're gonna build to a different standard, or like a lot of the remodeling contractors are gonna do, they're just gonna take out the screw gun and put 1 screw on one wood member and 1 screw in the other one, and they're done. So you can't make it any more difficult or simple than that. It's just one top plate though, and that's where the struggle has come in, is they don't understand where to do splices in the wall. Every builder, not the first one, but the second one on, their draftspeople and architects decided that they were going to use the structural strength of the top plate as part of their header. So if the original structure called out for like 2 2x12s for your header, then what they did is they took 4 T-studs, nailed them together. Doggone it, you can take that out. So they nailed 4 of this framing member together, and then pushed it up to the bottom side of the bottom plate, and then it all became one unit as a whole. The other thing that we've seen architects and draftspeople do is they have split all their double and triple windows apart, and they used a cripple made out of this product in between in order to reduce the sizes of all those headers above. And one structure went from having 8 LSL and LVL headers all the way down to 2. And they framed it in record time. You take 58 studs out of the equation, you can frame in a hurry. But it's not difficult, but you do have to train the people in the field. The hotel, motel, apartment builders, all those people, they all get it. They all, okay, we got it. Yep, off they go, because they understand advanced framing and what that means to them on a cost basis. So I hope that somewhat did, but there will be there are people out there. And somebody just asked about framing in Wisconsin. Yeah, there's 2 Yahoos in Wisconsin. You can send me an email and I'll give you their contact info.
Oh, there you go. Thanks. Yeah. So if anyone has any specific further questions on training, let's try to get to those. But hey, Brian, if you want to move back one slide again, just because I think the questions that are piling up here and that I have might be appropriate here on this slide, and really, what we're seeing in the green building movement is a sort of a foam-free aspect to it, right? There is a growing demand for that, interest in that. There are manufacturers who are responding to it. So, for example, we know we can get mineral wool now on the exterior. We can get it under the ground. We can get it in the basement walls as opposed to rigid foam. We also know a lot of tapes are being used in place of spray foam to prevent air transfer. And so I guess, just thinking of that, are there any ways that SIFS could, work with a foam-free like application?
Okay, well, the answer to that is yes. There's a bit of a structural component to that foam and being put in at a certain density. So there is some benefit as a whole, but that's one of the big reasons why we switched over to the new blowing agent, the HOF system, and formaldehyde-free as ozone depleting as humanly possible, was to get away from all those concerns. And I think that we've gone to the nth degree to prove up that system, and it's been costly to make the switch over. That new blowing agent is crazy. And if you look at the slide, the average temperature. Okay, so no doubt there was a lawsuit somewhere because the United States government got involved and said you have to list all of your insulation values as initial, and you have to do it at 75 degrees. Okay, so that's what it is, and they're all based off a K factor, so 0.150. But the interesting thing is the average temperature in North America is 55 degrees. So with the new blowing agent, you actually get a K factor of 0.139, and the R value goes up to 7.19 per inch. So the lower the temperature, the higher the R value. Fun fact. to circle back to your question, yes, there are a number of products that are being invented and being manufactured and that are forthcoming that offer advantages that and solve for challenges that the foam world currently has. Okay, I'll admit that. Everybody can admit that. So there are benefits to getting away from that. I'm not so sure that we're going to be able to on our side. Not that there's a lot of structural part there, but when you look at the fire side of things, okay, so we don't know where this, we have no idea where somebody is going to try to use this product in a wall. Is it for a wall stud? Is it for the top plate? What is it? Obviously, if somebody was to try to do this in the field and they did it with the wrong product and they used it for a top plate, and there was the unfortunate event of a fire, if it melted out, in our very first try at this, we used the wrong products and they failed. And we have a YouTube video out there on this where we talk through that. So that slide's coming up. Every company has a benefit to their product, and there's disadvantages. We've tried to do our darndest to minimize any disadvantage to using it because we have so many advantages. We're fully code compliant. You're on this slide. Our current product that's out there is the #2 SPF, and you can see that product right there when you read it and all the structural advantages to the modulus and whatnot compared to that 2x6 on the right. We beat them all. We do not have shear listed there because shear, when you look at it in this format, talks about for the 2x6 for a floor, and we are not a floor product today. We're a wall product. The next one, and this is in our technical evaluation reports. This is the allowable header loads as they've been tested, either one member, 2 member, all the way up to 7. And all your spans to the right, they list all of your L/240s that you need to have and the weights they can bear as they go. So basically, if you called out for 8x10, you nail 4 of us together and you have your 2x10. It's that simple. And nail them, screw them together, get them flat. Testing. Most people don't know about testing, so I've included some testing slides in here. So on our very first go, we had a great company out of Indiana, do some testing for us on our preliminary products. And the photo on the left is they were afraid of how much load that this was going to handle, so they bolted the structure to the floor. And we made it all the way up to 12,600 pounds in our very first try at doing testing on the compression load. We bent out of deflection, but we didn't break in that. In fact, they stopped. They thought if the board was going to break, it would go through their roof. And then they tested 2x6s, so we know what their maximum weight was. And then we did this in the center section. We did a 2-foot section, and that went to 38,000 pounds. So again, quite happy with our results. The next slide here. Okay, wind. Okay, this one here, we had a whole nother graph in, and so we took this out. When you look at, this is education for everybody, when you look at wind load tables, at the top it says pounds per square foot usually. Some manufacturers list theirs off as pounds per lineal foot. I'm not sure what all that means at the end of the day, but make sure that when you read the graphs, you're checking out to see how they displayed their information at the end of the day. So again, we passed all the wind loads for all of North America at 60 pounds per square foot. And we've tried to do all of our testing at the 24 inches, knowing darn well that we could be, if somebody wants to use this product at 16 inches on center, go ahead, you'll just use more of them in the wall. But on the maximum loads on compressive strength, and these are with wind loads of anywhere from 20 to 60 pounds. And so on the chart in the technical evaluation reports, which are online, it spells out all of this for you engineers and designers and architects. Okay, life safety, back to your foam question. Okay, so I'm going to circle right back to that right here. So when you create a brand new product, you have to make sure that you create a product that's no different than what the fire department is used to working with in the field. So my very first guy that I worked for used to be the fire captain, and so I went to too many fires, and I got to learn a little bit. Not that any of that information stuck with me, other than the fact that I didn't want to smoke in bed. But when we made our first products, we used a Type 2 foam. In the middle of it, the Type 2 foam, for the most part, no fire retardant in it, no nothing. If those foams, which are typically put on the exteriors of structures, if a flame gets to them, they melt. They don't necessarily ignite, but they melt. And they, do they help fuel the fire or not? I don't know, but we couldn't afford to have the product melt out, because then the air would free fall from the attic down into the wall cavity, and the air would help fuel the fire. So what we had to do is go to a Type 1 foam that had a fire retardant in it. We've switched to the new blowing agent, so our fire testing is through the roof. It's unbelievable. So the photo on the right shows a picture of 2 2x6s in plank after an E84 flame spread test. And the one on the left is taken from 5 feet in on the test. We have 90% structural capacity left over. So we had UL do all of our E84 flame spread tests for us. And after the test, all of them, 16 people came out of the woodwork, and they asked us, how'd we do that? Because obviously UL's job, or any testing company's job, is to burn up every product and fail it, because they represent the consumer. Well, because the flame only went 5.5 feet, they asked me, how'd you do that? And I said, you need to put the fire out, put them back inside my truck. I need to go home and file a few more patents. Okay, but this is an impressive test. It's 3,500 degrees, 2 high pressure propane leads blowing out propane, and they draw off. They push in from one end, draw out from the other, so that they can test the smoke, and they force that flame all the way across. And literally, we only went 5.5 feet on that flame. And so then here's what they give you for a test result. Is we ended up 23.7 on the flame spread, which technically qualifies us for a Class A fire rated wall stud, but it doesn't, because this only tested the Y-axis, because that's all we were testing, was to make sure that if a fire department, if they had to access the roof, 2 2x6s in plank are already charred. They're ready for failure after 10 minutes of a wall being on fire. So no fire department can go into access after 10 minutes. We don't want to change their mindset and say, oh yeah, it's safer to go up here. We just want them to know that in using this product, worse than what they're used to, but we are trying to create a better environment, a safer environment for that fire department to be able to work within. So for that reason, we will always have a foam component in the middle, and we will not trust somebody to be able to do that in the field. That's also why we have to have that adhesive that's heat resistant and moisture resistant to be able to hold that together. So it's the same thing that's used in I-joists, same adhesive that's used in doing any of the long joint finger joints. Even CLT, cross-laminated timber, it all uses the same adhesive. It's used in the world. We had another major company do all of our sound transmission testing, so this is our 5th solution. We ended up with a +6. We tested a 2x6 wall, and then we tested a thermally broken wall, compared one to the other, apples to apples, same type of drywall, same instances, and there was a score of +6 with a closed cell foam. We did go to an open cell foam and got to a score of +7. Not that we're going to use that, but we wanted to find out what the benefit of one was versus the other one, and there was slightly more, but not by much. So in this case, there's what you save, and I see we're over our time by a little bit, so I'll try to get through the rest of these. But so our this system, and my personal feeling is I just want quieter rooms quieter walls between the rooms, and so I'm still an advocate of using the RC channel. I just want to be able to sleep all night. Okay, offsetting building costs. There's a lot of them. Lots of stories can be written on this, but this is really what 2,000 fasteners look like. The next slide shows no, I guess we took it out. There's when you look at on average 58 studs that you take out in your top plate, it's a big, huge stack of lumber that's saved. And then these are all the fasteners that are attached to it. Is anybody that has used the system given a credit back? No, they have not. And it's because they don't know how to frame at 24 inches on center, or you're only using one top plate. We do have a structure coming up where we do have advanced framers, and they just can't wait. They're just going to fly through it. They already know how long it's going to take them. That sheetrocker that comes in behind that, that's 58 less runs that they have to run of mud times 3. There's going to be a big savings to them on that job, because that's how they're going for it, and they're going to make a super energy efficient structure. The end product looks like the picture on the right. The picture on the left is obviously done in Minnesota to Minnesota category insulation. Every joint is sealed, everything's caulked off. That black sticky crap everywhere. I'm not sure it washes off, but that's a nice job of how to look at what the insulation is at the end. And I think I was going to rattle off the brand of that insulation, but I won't. Okay, there is a field guide out there on how to frame. There's a professional one that's put together by the testing company, and then there's one that's done in layman's terms, done by us, which talks directly to carpenters in the field. Okay, obviously being from Minnesota, for those of you, this is the AKA Fish House FEMA trailer prototype. So it's a complete thermal break, 97%, it's actually 98%, between the floor, the walls, and the roof. And I know it's a type 2 insulation. But the point is, it's really simple. 20 degrees outside, we were sweating on the inside. We got a little wood burning stove in there, and we used 8 inches of wood every hour to hour and a half. And that's all we used inside of the structure to heat it. And it was too hot. We couldn't regulate the heat down far enough. So this is another product that's coming out. It's 2 inches wide and 3 inches deep, and 1.5 inches of foam through the middle. So all the retrofits in the country, and I tear the siding off, leave the sheathing on. Most of them built with 2x4s. They can screw this product to the wall, and so that they can then put an insulation in between from the outside. But then they have a complete thermal break through our this literally they call it a mini structural insulated stud. All right, Brett, it's up to you. That's all I got.
Yeah, definitely. Thanks, Brian. And we definitely can stick around here to answer a few more of all of your questions. You can stick around, right, Brian?
Yep, I can. Yep.
Yeah, great. So as those questions are coming in, I just want to say a big thanks to our board of directors, our volunteers, all of our members, all of you for joining us. We couldn't do this without you. Huge thanks to our big sponsors, Shrinergy, both microgrid solutions and batteries on the go, Mitsubishi Electric, efficient air-to-air heat pump systems, both integrated and mini splits, and of course, T-Stud, thermally insulated wall system. So big thanks to all of them. Thanks to all of you for joining us. And we do got some more time for questions here. And let's see. As those are coming in, I want to go back to one of the things you brought up, Brian. You were saying that there's potential for the SIFS to be extended to have thicker wall systems. And I think of the sort of passive house folks who are typically trying to chase after that R40 number. And please forgive me, I know it changes depending on your climate zone and which version of passive house you're using. But R40 is kind of that number that sticks out there in the walls. I think you had mentioned R30 was where you could get at least with blown in, but can you just speak to that a little bit?
Yeah, we were approached by somebody who wants to build, I'm not going to call it the best lead building in America, but they wanted to build the highest energy efficient building that they possibly could. and post and beam construction, and they asked us if we could get to a 50. And so something in that neighborhood. I know now we're going to split hairs on valuations of foam per inch. Okay, so that's a whole nother subject. So it would have to be completely tested out. But yes, there is a possibility to do something in the 9, 10, 11 inch deep range. The floor members that are coming up that have a complete thermal break through them, we can't do point loading because of the truss system, but we can do an even load for a floor. But you could easily stand those up and use them for a wall. And they have the same components. They have an unbelievably high sound transmission rate through them, like crazy. So we've been asked to do that one for a number of noisy commercial applications. And so yes, there are higher R values that can be determined. For the most part, you take 49.5 inches wide, which is the width of 1 unit of our finished product. And you just divide it by, so now we're doing 9 studs, which is 5.5 inches deep. 7 studs puts us at 7 1/8. So you just divide backwards and you can get the width of how wide that we can do a stud. But yes, they're all able to be used, and we've been asked for a number of things. We even did, we got asked the other day if we could make the wall stiffer, and we said, yeah, we can make it so stiff that it can't be used in seismic zone F. So basically, it's as rigid as can be. The ME in that one was almost 32 million, and so can't tell you how we did it, but yes, we got to 32 million. Crazy number.
Now, I know you and I were talking about this beforehand, but if someone really wanted to go all the way without, requesting too many changes, at least on the 2x8, I mean, what were I think if someone used a closed cell spray foam, they might get pretty close, right?
Yeah, they're okay. So I'm gonna say yes, they can, because I have seen I got to be careful. There's some really unbelievable closed cell foams that are coming out and are already out when they use that new blowing agent. That new blowing agent is like magic, and the quality of the foam job is second to none. It's like creamy. We're going to go through from the system that we have to a full open pour auto froth system in order to get our foam. I mean, the magical number is to get to the foam like 1.9 to 2.0. That is the magic number to get the highest R value and the highest STC value. That's what I've been told. 1.8, you get to slide off one way and slide off going the other way. So there is a perfect recipe that we will get dialed in as we ramp up production over the next 12 months. Before I forget, somebody asked about this, so I'm going to foam in basements. Do you have to still cover it up the foam with sheetrock, or you can't leave the foam exposed, whatever that rule is? And I'm going to say, yeah, you should cover it up. You don't want your kids down there eating it. You don't want your grandchild down there eating it. So, yep, cover it up. I know every state varies, and it's different from state to state on how they look at all those rules. But you got to decide for yourself. And I'm going to be an advocate of covering it up.
Brian, there was a question about SIFS, structurally insulated panels, and about how if your product could be integrated with those. And so maybe you could just give us a real quick, fast education on the difference between SIFS and SIFS and whether or not they could have any integration.
Okay, so integration, yes, because we finished their story. A SIP panel is an unbelievable, great, high R value, solid, energy efficient structure. I don't have anything negative to say about them. And so right now they still use 2x6s to wrap their center structure. And so they still get that, they don't have that thermal break through the 2x6. If they want to switch over and put us inside, so they can literally take that 2x6 out and stuff us in, and now they have a complete thermal break. 99, but they'd be 99.9%. I don't know what they'd be. Anyway, so yes, we can be integrated into their SIP panel to finish their story, and then we would knock their structure out of the park. So yes, it would be an easy plug and play situation. Easy. It's just like the open pore metal fabricated exterior skins on commercial buildings. Being able to slide in one of our structural studs into their panels. They're about 36, 42, 48 inches wide. They can easily slide us in and go from a non-structural to a structural product. Piece of cake.
What about insulated concrete forms, ICF?
Are you asking my opinion?
Just same question there, replacing the SIPs with ICF.
Ask your question differently.
Sorry, so let's just say the same. Yeah, so integration of SIFs with ICF systems, is it possible? Any opportunity there?
I'm sure that there would be. I know I have one shareholder that's highly active in that arena, and I know that they're interested in having a sit down. That's about all I can say on that subject.
There you go. Well, that's our time here. I don't see any more questions. So, Brian, I want to thank you and your team for putting this on. And just real quick before we wrap up, where can people go to get more information if they have questions?
Do you want me to really rattle off that website now?
Yeah, please do.
Okay, so it's the letter T and then stud. So T stands for thermal. So tstud.com is the website. And obviously, if you're okay, I got one more fun fact. If you're in Canada and you work for the Canadian government and you type in tstud.com, I will assure you that HR is going to come visit you in the morning, okay? Because that happens. Okay, it's really funny. It's really funny. Okay, so anyway, yes, it's tstud.com is where everything is on there. It's being updated on a weekly basis with more and more. Almost everything is being updated as we go, as we start dialing in the ease of the use of the product and we start getting our YouTube videos out there. And then my email address is really simple. It's Brian, BRIAN, at tstud.com. And then we still have the Facebook site, which is Tstud Energy. You can guess what the Tstud is on Facebook. It's not good. Okay, so but Tstud Energy is the Facebook site, so we'd love to have you like us there. And we're open for business, and we're able to ship to every state in the country. And we are working on our Canadian approvals now. That'll take a little while to go through that process, but Canada has asked us to come, which is fun.
Great, Brian. Well, thanks for your time. Take care, everyone. Have a good week.
Thank you.